All right, everyone, I'm Sam Charrington, founder of TWiML, and for this Solutions Guide Spotlight video, we're going to dig into weights and biases with Charles Frye, who's a deep learning educator at the company. Charles, let's jump right in and get started with some brief background about weights and biases.
WB is a developer toolkit for machine learning. So we've got our developer tools for software engineering, and now we're doing software engineering 2.0. In ML, we need developer toolkit 2.0, and it's the vision of weights and biases is to provide that software developing toolkit.
Awesome. And so tell us a little bit about the demo you're going to walk us through today.
Yeah, so I wanted to show off with this tool just how cleanly it can incorporate into your overall sort of like data science workflow. So I'm going to have something that's basically a hybrid of a slide deck and a Jupyter notebook into which I've slotted the weights and biases interface just like you would slot any other, Python-based software component of your workflow. So just to sort of like emphasize that, and I'll show basically just kind of things that you can do in that interface and the kind of things you might share with us. The sort of core developer tool that we've been working on first is logging information, saving information about your experiments so they can be reproduced, so they can be shared. And so I'll be focusing on those kinds of features in our interface.
All right, well, let's get it up and jump right in.
All right. So you can see here, this is what the raw form of my slides looks like. So it's literally just a Jupyter notebook, and then I can just turn it into this little, into a slide deck here. This tool is called Rise, by the way. It's a really, really nice tool. So yeah, we're weights and biases. We're building developer tools for machine learning. Maybe people probably don't need a pitch for why we need them, but I do like to show this to people. This is the developer tool stack I was using when I was a grad student at Berkeley. I just wrote, oh, hey, like I ran this thing on this machine, and it took this long. And oh, next time we should do it differently. And I can hardly read this now, and my coworkers couldn't read it then. So it was not a great solution for the problem of experiment tracking. And so weights and biases, one of our core things is giving you these rich interactive dashboards where all that contextual information you need to understand some piece of jargon, some number, some raw piece of system information, like I ran it on this particular machine. All that stuff is in a nice, rich, interactive dashboard on our in our web service.
Awesome. Well, we'll get a chance to see how some of these are built as we dig into the demo. Is that right?
Yeah, that's right. I'll show you the absolute raw, I'll start building one just with raw little Python, and then I'll show you some completed ones and what you can do. Once you've logged this information, you just throw the information up to us. We hold on to it. I like to say that you can pronounce our library name. Our library name is WANDB, W and B, the acronym for our name, but I sometimes pronounce it WANDB because we're like a database for your runs. So building this is like sending information to the database, and what I'm going to try and demo mostly today is how you take that information in that database and turn it into insights, shareable, actionable information about your ML pipeline.
All right, great.
There are a couple of different things here that we offer. I won't have time to go into all of them, but we do pretty much the whole pipeline from tracking your experiments, versioning your data sets and models, evaluating them, and also hyperparameter optimization and things like that. I'm going to focus mostly on the sort of experiment tracking side and the collaborative analysis side, so our dashboard tools and our reports tool.
And those are probably what the company's best known for and where the company started. Artifacts, tables, sweeps, these are things which came along later to complement that core experiment tracking that I think most folks associate weights and biases with. Is that right?
Yeah, I'd agree. I think it's a good idea to do one thing really, really well, and then use that to expand outwards and start doing more things well, rather than try and do everything at a mediocre level, and then try and make all of those things better at the same time.
Mm-hmm. Agreed. All right.
Yeah, so let's get started here. We'll just to show you that I'm really actually running this code here. Nothing, behind my up my sleeves, behind my back. Installing weights and biases, pulling it in. This is fully interactive. So if I wanted to just add something to what's going on here, I can do it. So like as we're going, if you want me to try something, I can go ahead and try it, run it. This is a Turing complete presentation here is what I'm trying to say. All right.
This is maybe a good time to note that, while you're running this on a notebook that's, on your machine or in the cloud or something, Weights and Biases it's delivered as a SaaS cloud service. So that's, thus the login here.
Yeah. Thanks for pointing that out. Yeah. So let's go ahead and start a Weights and Biases run with wanb.init here. So the sort of core unit in Weights and Biases is a run. That might be a machine learning training run. That might be a model evaluation run, a dataset downloading or uploading run. Any sort of unit of computation in an ML pipeline is a run in WNB. So we built one, and what's been printed out here is some useful information about this, a link to our documentation where you can read more about what's going on right here, our main website, and then also the specific places where your information is going to be available for your project, your particular run that you're currently logging, and where it's going to be locally on your machine.
Okay.
I think most people, when they're using Weights and Biases, they've got like, maybe they're running a script somewhere, maybe they're running a notebook, and then they go to these web pages to look at it in that web, in like that interface. But what we're going to do in this demo here, and is a cool sort of relatively recently added workflow with WNB, is look at those web pages inside of the notebook, like inside of where we're running our other code, the code that we're logging.
Mm-hmm.
So that's, I'm doing that here. Under the hood, what's going on here with IPython, you can display all kinds of rich information. So this is a nice little iframe showing our the web service inside the Jupyter notebook. And to send information to Weights and Biases, I call that wanb.log and put in a dictionary of information that I want to send to wanb. And there it is in our web interface. The metric hello has the value 1. So nothing too crazy has happened yet. But we could maybe add some more stuff if we wanted. You might be able to guess that the next thing I'm going to log is going to be called world. Don't mess with the classics. So this information gets sent. That was nice and snappy. Over to wherever the Weights Biases server is running, ours, yours, gets turned into a chart. And then as you are doing your exploratory data analysis, doing your machine learning training, whatever, these charts would be updating in your notebook or in a separate tab that you might open this same information up in.
Mm-hmm. And these data points that you're logging are kind of one-dimensional, like it's a series name and a single dimension.
Yeah.
I'm imagining you can do more than that.
Yeah, definitely. So I think the simplest thing to do would be, let's log some loss values here. So let's say loss/train. And generally our losses go down. So let's do our losses decay exponentially. So, this is what we'd like to see. Obviously, normally you'd be logging the actual loss of your neural network here, but I'm not going to sit here and write up a little PyTorch neural network live. That's probably a bad use of our time here together. So instead, I'll just fake it and say that this is just our losses going down. All right. Boom. And now this information is logging to Weights Biases. First one already logged. Let's see. This should start streaming in, and that should start updating in just a moment. And while that's happening, there we go. Like when you're training a machine learning model, those loss iterations, every couple seconds, you're probably getting a new loss metric, like how'd I do on this couple batches, how'd I do on this epoch, things like that, and that'll pop up live in WNB. This is still just a scalar metric, but now at least it's changing over time.
Yeah.
Maybe another thing you might log is your validation loss. And your validation loss, also that's probably going to decay, but you might not do perfectly on that one. So we'll just log loss, validation loss, see that live update. How did we do over time? Looks like we're probably going to do, almost as well, but not quite as well.
Mm-hmm.
And then we could combine these into a single chart, have our validation and training loss lined up with each other.
Mm-hmm.
Maybe neat little things that are also going on that I didn't have to do anything. All these system metrics are being logged while we're sitting here. You can see how much I'm writing and reading from disk, what's my network traffic for this process. Even though my GPU is currently running my graphics card and doing Zoom and doing all these other things, so it's cranking away even though I'm not doing anything in PyTorch or TensorFlow right now, but I've got that information, check its temperature, all the stuff you'd get out of NVIDIA SMI, HTOP, other things, but now instead of you just having to like watch it in a terminal and hope you catch something interesting, it's all automatically logged for you.
Got it. I've got to imagine that, when you're doing, when you're this far in the demo and you've kind of shown the simple logging and graphing, people immediately say, oh, that TensorBoard, how does this compare to TensorBoard?
Yeah.
And I'm sure you'll talk through that. And to some degree, the entirety of the demo is how does this compare to TensorBoard? But what's the quick summary on that?
Yeah. So the quick summary is one, like I used TensorBoard for some of my logging stuff when I was doing research, and I had to learn all of this stuff about kind of network administration, running a web service, right? Because that's how TensorBoard kind of asks you to do that yourself, open these ports, share them with people, so you don't have to do that anymore. And so that's a big relief. The other thing is that this is integrated with all the other things that are going on in W&B. So for example, I've turned on code saving. So while I'm executing my code, that stuff is being saved to our cloud service, and I can go up here and look, and attached to this run with all those metrics, with all those other things that are logged, is this Jupyter notebook here. And all the information that's been printed out so far. So in actual session history, you can see the changes that I made are reflected there. The cells that I ran, all that information is there. And in fact, some of the code I've even been writing, as this was running, is showing up in there. So you get this record of the code that you're running. And that's just one example of the kinds of things that you can log with W&B. Like this source code is getting logged there. I think. Probably to show you the real power of W&B, I can't be sitting here like pulling images on the fly and logging them. I'll show you an actual completed run in a second of what W&B can really do once you've instrumented it into your pipeline.
Got it.
But before I do that, I just wanted to say when you're done with a run that you're logging, you call wanb.finish, or when your script exits and you get this nice little cute history in Jupyter, it has this kind of nice little HTML representation here. In the command line, you get almost the exact same thing, including these little spark lines here that show you your how your metrics were doing. It's a nice cute little way to track very high level, did my loss in fact go down when I was training this network. But yeah, so let's show maybe what a more realistic neural network training might look like. So this is the dashboard here, and I've logged now a bunch of metrics while training a network on MNIST. So doing a hyperparameter sweep over a bunch of different hyperparameters for MNIST. So that's why there's this bright little blue sweep icon here. We have a tool for running those hyperparameter sweeps. But rather than focusing on the that higher level of how that hyperparameter sweep went, I'm looking at one of those runs, one particular component, drilling deep in on it and looking at it. So lots of metrics logged here. And here's another useful one. I've logged the gradients here with PyTorch models. That's a single line of code, wanb.watch, get a hold of all these gradients. And you can see they start off, these are histograms here. And you can see the values of the histograms, maybe looking at this guy, make it a little bit bigger here. It starts off with gradients with wide variety of values from minus 0.01 to 0.01. The histogram squeezes in, and by the end of training, the values of the gradients are all really small. So that looks like pretty good convergence. So that's a nice thing to be able to check. Somebody hands you a model, they say they trained it. You can check, did this person actually train this model to real convergence? Did those gradients really go down? Mm-hmm. That's a nice little thing. Then I think maybe the best piece of this that shows where we're doing something, more than what you could get out of TensorBoard is with the like collaborative sharing kind of features of W&B. So this, like, let's look at this chart here. So we got this validation curve here. Something not so great is happening in this validation curve. This is on the entire validation set, let's calculate the loss. And like zooming in here, it looks like it started off high, went down, and now is starting to creep back up. So we're converging. We saw that from the gradients, but oh geez, we're actually kind of overfitting there at the end. So there's, any number of metrics could possibly show you a problem with your ML model. So having them all in this interface together is really nice. But it'd be nice also, probably, I want to build a little chart here that shows the comparison between what's happening in our validation data and what's happening in our training data. So I can do that. Let me actually be really explicit here. You can edit these charts here. There's this little pencil here to click on. And you can edit these charts. So there we go. So we got our loss, we got our validation. So here's, this is a couple clicks. I've got this chart. Maybe you've got some beef with this chart, Sam. Is there anything that you dislike about the aesthetics of this chart that you might want me to update or change?
Yeah, I'm looking at, what was that last metric that you added there?
Oh yeah, that's loss/train batch. So that's like every single time a batch comes in, calculate the loss, log it to W&B. So that's batch wise, but I've lined it up with our validation loss, which is calculated on a like epoch wise kind of cadence.
And is the range the same on both of those axes?
Yep. So they're sharing a y-axis, they're sharing an x-axis. I can change that a little bit. Maybe I know that the loss tops out at 1 and it's useful to have that. Maybe I want to zoom in a little bit on, like, I don't need the beginning of training. That was going well. I really want to focus in on that. Mm-hmm. There's some other tools here, like adding a little bit of smoothing in different ways. Maybe I want to try, let's scroll down a little bit here. Different types of smoothing if you've got strong opinions. I kind of like Gaussian smoothing, so I'll probably do that. Mm-hmm. Let's see, there's some other things you might change. These are interactive charts, so that's a nice jump over. Like, I used to write all my plots in matplotlib, and you end up with a chart and then you end up with this like very static thing. So if somebody wants to know like a precise value, it's much harder for them to do that. But we've got these nice tool tips for sharing that kind of information.
And now, how much of what you're doing is kind of design time versus available to whoever you share the chart with?
Oh, that's a good question. You're asking, like, could somebody come in and make their own version of this chart if they don't like my choices?
Exactly.
Yeah. So you can choose how you share stuff within your team or within, like, the world at large. So there are some of these like more aesthetic things, like, oh, I wanted this amount of smoothing. That is going to be a little bit more design time, but there's lots of other features of the chart, like which particular runs are being shown, or like maybe some of the more complicated charts, you can change lots of stuff around about them, and that's what anybody looking at the chart can interact with it. And we'll see that in the demo that follows this one.
Got it.
But yeah, that's a great question. It is. I think in a team with a lot of trust, it's really nice to share the like completely raw chart. You can change whatever you want about it. Then if you maybe don't have quite that level of trust on your team, then maybe you can also sort of like duplicate a chart, and somebody can make their own version of it if they want, if they're on your team.
Mm-hmm. Got it.
All right, so we've got our chart here with this, and then it's just like one click to share this with somebody. You can either, if you just want to share the panel by itself, it's one click to turn it into a link and share it with people. But I want to just take this chance to show off this report feature. So maybe I want to tell my buddy who trained this model, pass it off to me, hey, we've got an overfitting problem. So now this has popped up in the W&B interface now we're seeing. And now I've got this nice rich editor where I can write this stuff like, our MNIST model is overfitting. And this editor is actually really nice. It's built sort of like inspired by Notion or Dropbox. If you've used a Dropbox Paper, they're like editing tools. So there's lots of stuff that you can add in here. nice aesthetic things like, look at that validation loss. That's no good. So those kinds of things. There's also, you can add additional types of analyses here. Like I could add, another set of panels that maybe compare it to some of the other things in our network or that we've been training. So this is now that was just at a single run level. Now we're looking at like I could build a similar chart here that would compare training and validation loss for like lots of runs at the same time. That artifact of that report is something that you can share, edit, put on the public internet, share only within your team, all these kinds of things.
Yep. And we've been talking about it in the context of collaboration within a team, but I've long been impressed by one of the things which Weights and Biases has done, which is allowed people and really encouraged people to build these analytical reports and share them essentially as blog posts. It's, in some ways like a blogging platform for data scientists. And I'll often see links being shared around on Twitter or what have you, with these kind of rich embedded graphics. And I think what's powerful about that is that as you've kind of gone through the demo, it's not like somebody did this project and then, wrote a blog post and created a bunch of graphics. It's like the creation of the visualizations is a part of the analysis that they did. And then they're just sharing that work as part of, as a publishing step, but it's not a separate creation step, if that makes sense.
Yeah, absolutely. That's definitely become a bigger part of like my workflow is I log a bunch of stuff to W&B. I get in that interface that I was showing, and I'm building these charts, throwing them into reports like this, and then polishing those later into a full blog post, or maybe keeping them as just like sort of notes to self, right? The one of the trickiest collaborators is yourself 6 months from now. They don't respond to emails. They're inaccessible on Slack. And sometimes it turns out that they kind of hate you,
And you think they should know more than they do.
You think that they would know more than they do. We do publish reports from our users who, like, if you do something interesting and you really want to polish it into a nice blog report, we share that kind of stuff in our fully connected blog publishing platform. So there's lots of stuff here on different things. Some of these are like very MLOps oriented. Some of these are much more like sort of tutorial, how to use LSTMs in PyTorch versus something like, what's a good... Reproductions of Papers. We sponsor folks at the Reproducibility Conference to write these sort of like take their reproduction of a paper from a big conference and turn it into an interactive report like this, where you can like dive in and see. You can click all the way down to seeing like which machine were they running this on and which GPU was it using, and all that like precisely detailed information that when you're reading a paper that you want to implement, you really wish you had your hands on,
Mm-hmm.
All right, we'll come back in this interface here. So that was a project that sort of I built and I knew lots of stuff about it. You can also look at a project made by somebody else, like one of your coworkers here. This one is a project done by my coworker, Stacy. And she's logged something with our tables feature, which is really, now we're really getting beyond what you can do with TensorBoard, because what this has here isn't just the images that went into the network and the outputs that came out of the network. This is now actually basically like an interactive pandas data frame on which you can apply like different kinds of transformations.
Mm-hmm.
So with this one thing I might do, like things that you can do here are like a group by, right? So Stacy logged this table. She was just logging sort of like the core information, just like here's an image, here's what the outputs were, here's things like the network's like logit outputs, that final last layer, what were all those values. All that stuff is stored in here. And then I can sort of construct a query live inside W&B, or even inside W&B inside my Jupyter notebook, to look at that information, find stuff that's interesting. So I've grouped by what the network guessed that something was. So it guessed that these were ankle boots, which looks pretty right. Guessed that these were pullovers. These are trousers. So like I can just get a sniff test of how my network is doing, or I could actually go in here and not just group by, but also filter and say, did my network get this right? Was the guess by the network equal to the truth? Are the ground truth and the truth equal? If they're not, show me all my network's mistakes. So this table is, as I'm doing this, maybe now I want to call this, I want to rename this section and call it network mistakes, because I'm building this table that's going to show me all the mistakes my network made. And here we go. It's calling some things sandals that are clearly sneakers. This is a dress, probably, or a skirt, not a shirt. So we've got built that. I can compute new columns on the fly here. Row count, see how many mistakes there were.
What I'm seeing here is a tool that you are applying to kind of debugging network errors, but in the visualizations, the group bys and things like that, I see something that also looks like something I might want to use for EDA, exploratory data analysis. Is that an element of this as well?
Yeah, absolutely. Actually, I would think of debugging neural networks as a form of exploratory data analysis, because in the end, data goes into networks, and what comes out of networks is still data, right? Tensors in, tensors out. And your network's outputs might be if it's an embedding, maybe that's the input to somebody else's network, and they would be doing exploratory data analysis on your embeddings. So I actually like that this tool elides the difference between debugging a model and exploratory data analysis.
And I think what I was asking, I appreciate that observation. I think what I was asking was, is the tool designed for it? Do you see people? Could you, load some data and then do the same kind of analysis with the data that you loaded instead of whatever other, EDA tool or framework you might otherwise use? And is there some advantage to doing that?
Yeah. So, so you literally, if it's your network outputs, you got to kind of build the information that goes into here, so incorporate it into your training code. But if you just have a data frame, you can turn a pandas data frame into one of these tables in a line. The advantage of doing this is that now it's tightly tied in with the rest of your pipeline. So just looking here, I can see for this run which model and which data were used here. So this is the actual information that is our that table. Underlying, I can find the literal JSON where all this information is stored, and I can take that, back up a little bit and say that literal information there was based off of this model and this test data, and the code that was executed to create that is this code. So I showed you that source code is logged. This model here, I can introspect this model, but not only is everything now sort of like introspectable, it's also connected in like a nice little graph of connected things. And if we quickly go to the actual web interface rather than inside of that thing, we can see the actual graph view here. Actually, Stacy did a lot of runs in this one, so this one takes a second to pull down all that information. But here it is. Here are all the things that were involved, all the jobs that she ran, all the things that she created, and connected with each other, and available for drilling down in. What did she do? What was the training data? Let me take a look. I can actually look at the specific data that she used for a particular run.
Got it. So kind of summary answer to the question is, yes, you can do that very much by design. Part of artifacts, which we said we weren't going to talk a lot about, but we're digging into now, and create some unique opportunities.
Yeah. So I would say, instead of admitting that I talk about something I said I wouldn't talk about, I would my summary of the second one would be, your exploratory data analysis is now co-located with all the other information in your model pipeline, which is where it should be, not in some random Jupyter notebook, or in the case of an important analysis I needed once, only available as a .ipynb checkpoint on one single, computer that happened to not garbage collect it. That's no way to live.
Indeed. Awesome.
Yeah, and I think there's lots of tools that offer a lot of things like the things that I've been showing. At least one piece of those things. One cool thing that we added recently that I don't think really any other tools have as good of an offering for is tracing your PyTorch code and sort of seeing at like a millisecond or microsecond by microsecond level what's happening on the CPU, what's happening on the GPU, and why is training taking so dang long to run. So that's what this little last demo is here. This guy, it's a very rich interface here. There's a lot of information. It's kind of overwhelming at first sight. Gives you literally what was happening on the CPU and GPU while a training run was going. So here I can see how did the CPU instruct the GPU to do stuff. I can see my forward pass here with my linear layers, my rectified linear layers. I can see the backwards pass, which literally runs backwards. We've got the loss shows up first, then things like the linear layers and back, and I can see which CUDA kernel was running. Is it my favorite CUDA kernel? Is it a CUDA kernel I don't like so much? And get like really precise information along with statistics, and all this stuff again is available in in this WNB interface where it can be co-located with other information and turned into reports. So with this one, I've looked at that one before and diagnosed that we've got a real problem here with our data loaders. So I could turn this into a report and say like single process data loaders are killing us.
Got it. And is this particular feature, is that PyTorch only?
Yeah, it's based off of this really nice PyTorch trace viewer tool, which is in the end, actually, web developers really like this for watching what's going on a web page. I think it's general enough that it'll be able to sometime soon track TensorFlow runs as well.
Got it. Very nice.
Yeah, so those are the core demos that I wanted to talk about and walk through, share some of those features, sort of emphasizing both how rich the information you can put on WNB is and how rich the tools are for taking that information and turning it into not just a data dump, but actually insights, information that you can share with a stakeholder or a colleague or the community at large.
Very good, Charles. Love that we did this live in the notebook and got to cover lots of interesting functionality. So thanks so much for sharing with us.